Look up into the sky on even a not so dark night and there's a good chance you'll see it. Mars, the red planet. For centuries, this distant world has fascinated humanity. In the late 19th century, astronomers believed they had spotted canals on Mars, which led to a theory that intelligent civilizations might be living there. By the 1920s, scientists speculated that radio transmissions should be coming from Mars. Even as recently as the mid-20th century, some scientists believed there might be still signs of life on Mars, perhaps in the form of microbes or even vegetation. But today, we know that Mars is a barren, desiccated desert planet, once home to vast rivers and oceans, but now devoid of life for billions of years. So what if we could change that? What if humans could reverse the process? Resurrecting Mars like some kind of planet-sized Lazarus. Right now, some very clever people like Elon Musk and Jim Green, the former director of NASA's Planetary Science Division, believe that terraforming Mars is not just a hypothetical dream, but something that could become a reality within our lifetime, or at least within the lifetimes of our great-grandchildren. In today's video, we're going to explore the latest science and research on terraforming Mars and try to figure out if this idea is really possible or if it's just the ultimate pipe dream. Let's start by looking back in time. If aliens had arrived in our solar system about 4 billion years ago, they would have probably been able to tell that Mars was the most promising candidate for supporting life. Back then, Mars was a water world with great seas fed by surging rivers. Waterfalls cascaded over Martian rocks and warm rivers lapped at rugged shores. This would have made the red planet a beautiful, inviting place, potentially even home to simple life forms, much like early Earth. At the time, Mars also had a thick enough atmosphere to trap heat. It had a magnetic field, which shielded the planet from harmful solar radiation. This made Mars a far more promising candidate for life than the young, violent Earth that was still in the process of cooling down. But as we know, Mars's favorable conditions didn't last. About 3 billion years ago, the planet's magnetic field disappeared. Without this protective shield, the Martian atmosphere was slowly stripped away by the solar wind. The planet's atmosphere became too thin to sustain surface water. And by the time humans evolved on Earth, Mars had become a cold, desolate world, a place that was hostile to life as we know it. Now, this presents a massive challenge for anyone hoping to colonize Mars. Mars's atmosphere is currently 96% carbon dioxide, with the remainder made up of argon and nitrogen. This is problematic for a couple of reasons. A mix of carbon dioxide at 10% is enough to cause suffocation for humans. But the real kicker is atmospheric pressure. It's just 0.6% of what we feel here on Earth. The pressure is so low that if you were to step outside without a spacesuit, your blood would literally boil in your veins. And that's not even factoring in the temperature, which is consistently cold, an average of negative 63 degrees Celsius. In the Martian winter, temperatures can plummet to an astonishing negative 140 degrees Celsius, colder than anything on Earth. Even the hardest of adventurers would struggle to survive in that kind of cold. But there's another huge obstacle: radiation. With no magnetic field, Mars is bombarded by intense solar radiation, and if you were to land there, you'd be exposed to about 20 times the radiation that we experience here on Earth in a single day. This makes long-term habitation incredibly dangerous without proper shielding. So at this point, you might be thinking, well, if it's that bad, then why even bother? And you'd be right to ask. NASA ended a study in 2018 on the feasibility of making Mars habitable, concluding that terraforming Mars with today's technology is simply not possible. Any attempts at terraforming would need to be done far in the future, after we've developed far more advanced technologies than we currently have. But does that mean that the dream of terraforming Mars is entirely hopeless? Not necessarily. While we can't terraform Mars today, that doesn't mean that people aren't working towards that goal. There are researchers and engineers actively working on technologies that could, one day, make Mars more hospitable. This is a long-term project, and while it might be beyond our reach today, it's possible that future generations could live to witness the beginning of Mars's transformation. So let's start with one small essential step towards terraforming Mars, improving the soil quality. If we're going to create a self-sustaining colony on Mars, then humans will need to grow their own food. And for this to happen, we need to figure out how to make the Martian soil suitable for growing crops. Right now, Martian soil is a nightmare for farming. It's hard and clay-like, and it also lacks the essential nutrients that Earth plants need to thrive. Additionally, it's full of percolates, toxic compounds that are harmful to both humans and plants. But that's not all. Martian water is briny and contains high levels of salt. And salt water is terrible for growing crops, and desalinating it would require massive resources. However, scientists are already looking at ways to solve this. One exciting development comes from the Iowa State University, where a team of researchers led by Pooja Kasi Vishwanathan have proposed using cyanobacteria to desalinate Martian water. Cyanobacteria are microscopic organisms that can absorb and remove salt ions, making water suitable for plants. The team showed that they could grow alfalfa in simulated Martian soil. The plan is to use the alfalfa as compost to gradually improve the soil, turning it into something that can eventually support more complex crops. In addition to Iowa State's work, a team at the University of Bremen in Germany is looking into using cyanobacteria to grow duckweed, another fast-growing, nutrient-packed plant. The goal here is to create a circular farming system where the plants are composted back into the soil, enriching it with the nutrients necessary for growing more delicate crops like fruits and vegetables. And while improving the soil is an important first step, the real challenge lies in thickening Mars's atmosphere. Without a substantial atmosphere, Mars will never be able to support human life in any meaningful way. The atmosphere is thin, and it's continually being stripped away by the solar wind. So, what if we could somehow stop this process and begin to restore the atmosphere? This is where things get really interesting. The key to this is Mars's magnetic field, which disappeared billions of years ago. But if we could somehow reactivate Mars's magnetosphere, it might slow the process of atmospheric loss and give the planet a chance to rebuild its atmosphere. But that's not something that we can do with current technology. However, James Green, former NASA planetary science director, proposed a creative solution: a giant magnetic shield. Green's idea is to place a large dipole, a device that can generate a magnetic field, at the L1 point, a gravitational equilibrium point between Mars and the Sun. The magnetic field generated by the dipole would protect Mars from solar winds, preventing the atmosphere from being stripped away. And over time, the atmosphere would thicken, which would lead to a rise in pressure and temperature, and this would eventually create a habitable environment. This idea sounds like something out of science fiction, but Green believes that it would be possible within the next few decades, well within the lifespan of our great-grandchildren. Of course, creating a breathable atmosphere is only part of the challenge. Mars is still freezing cold, with an average temperature of -63 degrees Celsius. One idea to address this comes from Elon Musk, who famously suggested detonating nuclear bombs over Mars's polar ice caps to release carbon dioxide and other greenhouse gases. This would help raise the temperature and begin melting the ice, which contains a significant amount of water. While this is a little controversial and it's a dramatic solution, it would, in theory, help warm up Mars. However, experts believe that even if Musk's idea worked, it might not be enough to create a sustainable environment. Mars still lacks the resources to generate the greenhouse gases needed to keep the planet warm for long periods. This is where alternative solutions like mining methane or harvesting carbon dioxide from Mars's surface might come in. If we could extract enough CO2 or methane from Mars's surface, then we might be able to thicken the atmosphere enough to make a real difference in terms of heating the planet. And finally, once we have a thickened atmosphere, we need to consider how to make it breathable. Currently, the Martian atmosphere is mostly carbon dioxide, which humans can't breathe. However, on early Earth, cyanobacteria played a vital role in converting that carbon dioxide into oxygen. And it's possible that certain types of cyanobacteria could survive on Mars and begin the process of doing the same there. Over time, this could potentially help create an atmosphere that's at least partially breathable. Even then, Mars's lower gravity and thinner atmosphere would still make it a challenging place to live. However, getting to this point would be a monumental achievement, one of the most impressive feats in human history. So, while terraforming Mars might seem like an impossible task, it's not entirely beyond the realm of possibility. It will require breakthroughs in technology, huge investments of time and resources, and a lot of patience. But the dream of terraforming Mars into a habitable world might not be as far off as we think. James Green's magnetic shield could become a reality in just a few decades. Innovations in circular farming and cyanobacteria could start improving the soil today. And while the idea of nuclear bombs over Mars's poles might sound outlandish, it's one of the many ideas that could one day play a part in making Mars habitable. In the future, we might see a temperate Mars with oceans and the potential for human life. It's still a long way off, but it might be closer than we think. And while we may never see it ourselves, we might just leave a legacy for future generations who will one day live on a transformed red planet. Thanks for watching, and don't forget to like and subscribe for more videos on the future of space exploration and our quest to turn Mars into a place that we can call home. See you on the next one.